In this video, let's quickly have a overview of linked list class. In previous videos, we have learned all about ArrayList class, and in this video we are going to take a look into linked list class overview, and in next video we will learn more about linked list with lots of examples. Okay, so look at here in collections hierarchy, linked list class implements list interface as well as Deque interface. Linked list internally uses doubly linked data structure to store data elements. So doubly linked list is a data structure. It holds a collection of nodes. For example, let's say this is the node, okay, and each node in a doubly linked list is divided into 3 parts, and this part contains the pointer to the previous node, and this part contains a pointer to the next node, and this middle part contains data. Okay, so double linked list is basically a collection of nodes, and each node consists of these 3 parts. Linked list internally uses doubly linked list to store the data elements. Okay, great. Like ArrayList, linked list also contains duplicate elements, and linked list class maintains insertion order. It means linked list class also preserves insertion order, and linked list class implements queue and deque interfaces. Therefore, it can also be used as queue, deque, or stack. And linked list class is not a thread shape. It means that whenever you want to use linked list in multi-threaded environment, then you should have to explicitly synchronize linked list class. Okay, and we have collections utility class in collections framework. So collections utility class provides static methods to synchronize collection classes. For example, collections utility class provides synchronized list method, so which we can use to synchronize a linked list class. Okay, so this we will see in example section. All right, great. So now we know that linked list and ArrayList both classes implements list interface. Okay, and there are a few key differences between them. So let's quickly understand the difference between ArrayList and linked list. Okay, so ArrayList internally uses arrays to store the data. It means that ArrayList is an index-based data structure backed by array. Okay, on the other hand, linked list internally uses doubly linked list to store the data elements. So this is the first difference. The second difference is that insertion, addition, or removal operations are faster in linked list, because in linked list there is no shifting shifting required, because in case of ArrayList, if we remove any element in the middle, or if we add any new element in the middle of the ArrayList, then there are a lot of shifting required, because ArrayList is backed by array. It means ArrayList internally uses indexes to represent elements. For example, so look at here, this is the ArrayList, starts with index 0. Let's say we have 10 elements within ArrayList. If we remove any element at the middle of the ArrayList, then there are a lot of shifting required. Okay, sometime if we add a new element to the ArrayList, then ArrayList internally creates one more array to store all the data from the original array into the new array. So this is how the ArrayList resizes its structure internally. Okay, got it. So whenever you have insertion and removal operation at the middle of the list, then linked list is the best choice and it's faster. Okay, great. And the third difference is linked list consumes more memory than ArrayList, because linked list internally uses doubly linked list, right? And doubly linked list is basically contains a collection of node, and each node consists of 3 parts. So look at here, this is the node and it consists of 3 parts. So this part, middle part, contain data, and this part contain next pointer to the next node, and this contains pointer to the previous node, and some amount of memory is required to store these references also. Okay, and hence linked list consumes more memory than ArrayList. So look at here, ArrayList basically requires memory to store element and its index, and in case of linked list it takes a little bit more memory to store pointers, that is next and previous pointers apart from data. All right, so this proves that linked list consumes a little bit more memory than ArrayList. All right, so these are the few key differences. Let me recap the differences. In case of structure, ArrayList internally uses array to store the data elements. It means ArrayList is index-based data structure backed by an array, and linked list internally uses doubly linked list to store the data elements. Okay, this is how the structure implemented inside ArrayList and linked list. And in case of performance, whenever you have operations like insertion and deletion at the middle of the collection, then linked list is much more faster than ArrayList. Okay, and in case of memory usage, linked list consumes more memory than ArrayList, because linked list internally uses doubly linked list, and doubly linked list is a collection of nodes, and each node consists of 3 parts, so each part takes some amount of memory. That's why linked list consumes more memory than ArrayList. Alright guys, this is a quick overview of linked list class and the key differences between ArrayList and linked list. In next video we'll understand more about linked list with lots of examples. Alright guys, I will see you in the next one.